All right, folks, for track 3, we have Jon Moroney. He's going to be presenting Building a Better Database, how GitHub structures their advisory database to drive developer outcomes. Jon, feel free to take over.
Cool. Thank you much. So yeah, I'm Jon. Here's a brief bit about me. All my deets are on my GitHub profile. Long story short, I've just been doing technology for a little while now. I work in the GitHub security lab. Our explicit goal is to secure the world of open source software because it's kind of broken. So what do I do? Ooh, that emoji did not come through. That's foreboding. So I'm a librarian at like TLDR. This is what I do. I curate, along with a team of other security analysts, the GitHub advisory database, and we concern ourselves with creating a correct, complete, and concise database of security information for developers. And so first and foremost, what are we trying to do with this database? As the title sort of alluded to, we're trying to drive developer outcomes. Particularly, we're trying to fix people's code. There's a lot of broken code out there, and if we can get people to stop shipping known vulnerable software, we can at least start focusing on the unknown vulnerable software. A few axioms here to start with. Generally, developers do want to do the right thing. They just don't want their time wasted. That is, in large part, what drives this. Yeah, and people will understand that security is hard and that there will be errors and understandable mistakes can be forgiven. So what is a good outcome? A good outcome is when a security issue is disclosed, we can minimize the time gap between the disclosure and actual fixed code being shipped to production. That's a good outcome, or that's how to measure a good outcome anyway. This is a very manual process. We have humans involved, and we want to maximize the effort or maximize the impact of the human effort spent. We want to avoid the tar pit of trying to do the impossible and producing nothing of value. All right. So there's an interesting emoji setup, but this is the developer's perspective in like a TLDR sense of what the CVE system looks like. There's a lot of vulnerabilities out there. Which ones do I care about? If you look at this number here, on this particular day last year, there were, 171? This is 21 advisories an hour. If we as a community are asking developers to just read every CVE, they will do nothing but that. They won't actually do their actual job of development, which is a problem. So this is what we do at GitHub. We have users on GitHub, which are unsurprisingly developers, but they follow a number of patterns. They use packages from a number of these, what we call ecosystems. These ecosystems are bijections. Each of these corresponds, or we can set up a naming system between each of these and the packages in their corresponding registries. And for those unfamiliar, Dependabot, which is this logo here, this is the GitHub scanning tool. You can think of it as the manifestation of the database itself into action. So CPE. This is how most of the industry programmatically indexes advisory data. And we don't use CPE. We don't use CPE because it's not a bijective system. And what you can see here are 4 different routes for 4 different NPM packages. CV numbers up there if you want to take a picture or whatever. And this is how we do it, where each of these would be subordinate to our NPM ecosystem. This means if you're writing a scanner, there's no guesswork. You just go and say, here's a string. What is the corresponding ecosystem where I do the lookup? Do that lookup, and bam, that's what you're talking about. Interesting. Okay. So there's supposed to be some emojis on this slide. That's cool. So I'm going to skip through this because it doesn't really matter. Okay, so imagine a supply chain. There are producers on the left, there's consumers on the right. This is what the bug looks like. The bug is on the left, the problem is on the right. Ideally, we have this alert chain, which are these interrobangs here, which is the source of the bug is alerted, they fix it, they tell their downstream consumer, whether that's a give or a take relationship, hard to say, but ideally there is a communication channel where they can say, yo, something's wrong. And that would propagate down through the emojis, which went on vacation today. Yeah, this is the reality that we live in, though, where people cover up their warnings. If something isn't critical to them, they don't care. It's a waste of their time. And this is just what we have built over the last few decades, and it's a problem. So let's take a look at a single CVE of interest, which, wow, I cannot read this. So this is a CVE discussing a problem in some package on PyPI. I forget the name of. This is a zoom in on the CPE data, which I think that CPE data says everything on PyPI is affected by the CVE, just throwing that out there. So like you do need a schema, but you also need like operational quality too. So, but if you dig into what this thing is about, you'll see here, this is the reporter, or this is I think the entity that got the CVE assigned. And they're saying, hey, do this pip3 install Mercator at this version. And this bit I've highlighted here is telling pip the tool to go and install a package from a non-standard package registry and to default to trust it. The maintainer of this project responds and says, hey, I think you're doing this weird thing. I think in that second line there, I think they mean threat model instead of thread model, but anyway. They notice that there's a problem. This post is 2 months before the CVE got assigned. This still got assigned and it still exists. Like this is a CVE. It's not in the GitHub database, or not in our reviewed set anyway. But this is a problem. This is something that we can't blame developers for disliking alerting systems if this gets through. This is pretty blatant. Put succinctly, we can't expect better if we're not going to enable better. So how do we do that? How do we actually make things better? So at GitHub, we have our readers are simply developers. We have access to their source code because that's what they upload to GitHub. We generally don't have access to their build systems or to their deploy environments. So we don't have that information to work with. So we have source code to inspect. Along with that, we tend to have manifest and lock files, which are common but not universal. If we have those, we have different degrees of precision of knowing what pieces of software they're using. If we have a lock file, great. We know their entire dependency tree down to the specific versions. If we have a manifest file, we tend to have something a little less precise. Many developers will say, I want to use package X above version 1, but below version 2. And what that ends up at deploy time is kind of up in the air. So we have to deal with that. Like that's just an inherent problem we have to deal with. So what we do is build this database. We index vulnerabilities on packages themselves rather than necessarily the source code underlying it. This gives us a 0 false positive by design. That should say as well, this is a lossy translation. That should say by package matching because security issues are contextual as well. Whether or not, if you're just pulling a package into your build system doesn't necessarily mean you're using it in a vulnerable way, but at least we can say, we see this in your build. Here's an alert which is likely to be relevant to you. This also gives us the ability to do a quick delivery should it be necessary, which spoilers, it is. This gives us a common language to discuss vulnerabilities with developers because they know packages, they know version ranges. All of our security claims can thus be validated and contested, which will come up a little bit later. Oh, come on. All right, so I wrote all these slides in Keynote and then translated it to Google Docs and now to PowerPoint. Did work on my machine. All right, so I need you to use your imaginations again. What we have on the left here is a developer with a bug in their software and someone who has discovered the bug. On the right is a developer consuming the software from a package registry like PyPI or NPM or whatever. The idea is that is a broken communication chain and security scanners can bridge that gap. There should also be just a number of reports here. This is the single instance. This is like it multiplied. So we can deliver many alerts downstream with one single tool. That is to say, the tool scales. This is what this looks like in practice. This is probably my favorite slide, or not my favorite slide, my favorite graph, despite me kind of also hating the graph. The time intervals on the bottom there are 2 hours apiece. This is log4j, which I'm going to assume you're all familiar with. All right, no one said no. Cool. This is where we went live with Dependabot alerts. This time delta is 12 hours, and that gets us to, like, roughly we get to the 50% mark of fixed downloads of the log4j package as measured by Sonatype, who are the people that run Maven Central, which is where log4j was hosted or is still hosted. We don't know our direct impact, right? Like, we're not the only ones publishing this information, but it's probably not zero. What I like about this is that it takes 12 hours to get from 100% of vulnerable downloads to 50%. The second link on the right there, if you go and check this out, Sonatype is doing an ongoing log4j analysis of who's downloading what. As of 3 days ago, I think it is, the world writ large is at 33% vulnerable downloads. So to get to 50% in 12 hours and then have years to get whatever that remaining percent is, I think is a reasonable sign of efficacy. This is a longer view. The red line there is the log4j event, roughly. And what we have here are PRs merged, PRs which were open, or sorry, pull requests, PRs, which were opened by Dependabot for security reasons, not specifically log4j, because I'm not a data wizard and data is hard. But all PRs which are then merged. And what we can see here is it's roughly level, dips for the holidays, comes back and at an elevated level, which I think, or which I hope is indicative of a sign of confidence in the Dependabot system and just an indication of how many updates are happening. These are weekly numbers, I think, and they are too small for me to read as well, which is great. So we publish our data as open source information. You can come to our advisory database repo. It'll be at the end of the slides, PRs welcome, etc. This guy giving a talk is not a GitHub employee. He is speaking at GitHub Universe, which is our company conference, and he is espousing the virtues of our data being open. I think he works for the company Anchor. They make the tool Gripe, and they are using our data, and they love our data because they can go and inspect why everything is as it is. They can and have suggested fixes, and the industry writ large gets a better database as a result. That said, we are not perfect. We do have issues. This is an issue opened by a guy named Josh Bressers, which I think he's known to a few of you here. He's pointing out a flaw in one of our ecosystems, which is our Maven ecosystem, in that we do not distinguish between what package registries we're downloading from in our Maven data, and that's true. We discussed this in the open. The fix is pending, basically. So we use a format called OSV, which doesn't allow that level of precision yet. There is a PR open, I think today. I was supposed to comment on it a few days ago, but anyway, that's going to happen, is where I'm going with that. The short bit of this slide is we are not perfect. We have issues, and they are out in the open for you to see. Similarly, we get advisory data wrong sometimes because we are human. We have a dual mandate of being both fast and accurate, and we live in a world of imperfect information. In that scenario, we cannot be perfect all the time. This is an example of us errantly putting 2 packages on an advisory and the maintainer of both of those packages coming and telling us we're wrong. Check it out. The thread is still live. We can't do everything. We are not the database of everything. We have a very specific scope, which lets us spend our human time in a more valuable way than trying to do things that would be very low value or very hard relative to their value. This is a common one, C and C++ support, which is far more complex than anything we do today. We're talking about it. We just don't have a solution for this today because there isn't really a there's no standard C and C++ package. Yeah, so we are on a journey here. We are not on a straight road. Um, yeah, the path we're wandering is not straight, and we are course correcting as we go. So if you're interested, we would love your help. We cannot do this alone. If you write advisories, please call out your artifacts. Speak in the language of your downstream consumer. If that means Maven packages hosted on Maven Central, call those out in your descriptions. This is a CVE written by the Spring Foundation, which generally does quite good advisories, in my opinion. They could have called out the specific jar file, or I think they're jars, or the specific Maven artifact relevant for this advisory. I hope they do so in the future. If you don't if you're a writer of advisories and you don't talk in packages, talk in the language of whatever you deploy to your users, be that binary files, be that commits, be that, I don't know, CDs, like whatever. Just speak their language so that they can more appropriately take action. It'll help us and it'll help them. If you read advisories, call out the errors. This happens to us occasionally where we get something wrong and the community will sort of come together and tell us we're wrong. This is a good thing. This is a self-correcting mechanism that helps us get better over time, and our errors are limited in time scope. If you want something we don't provide, build it. This is my favorite tweet. It is someone making fan art about Dependabot, which is a security scanner. And it is simply heartwarming to me that someone went and made fan art about a security scanner. There will be if you build something yourself, there will be signs if you are doing something that is valuable to other people. Hopefully you'll get something like this. So we're librarians. We maintain a database of advisories that we hope are trustable by the community. They are open to inspection. They're open to contestion. The data is Creative Commons by 4.0 licensed. PRs are welcome. And yeah, with that, there's a lot of work to do, and we can use all the help that you're willing to give. Yeah, so with that, I'll go to questions. There's one over there.
Sorry, we had one online and the mic's coming that way.
Oh yeah, sure.
So you compared GHSA to NVD and CPE and ended with BAM, but both systems seem to include versions that make big assumptions. For example, under 5.6.7, despite there being no evidence that all prior versions were tested.
Sorry?
So like they're saying, like in a CV description, you might say a version under 5 is affected, but they didn't go back and test every version before 5.
Right. Yeah, so we have imperfect information to work with is sort of the short version of that. It is the sort of conservative thing to do to say all versions under the tested version are affected. Part of the community contributions that we take are, if that is not correct, please come and tell us. Sorry, does that answer the question?
I was just going to pile onto that a little bit because I was having this conversation before this talk. For the audience, I work on OSV, and we're far more interested in accurately identifying a version that gets you past the vulnerability than we are a version that precedes the vulnerability being introduced, because sometimes that isn't known, right? And normally the path is to upgrade forward, not to be going, I'm so old I dodged the bullet.
Yeah, exactly.
You talked about limitations with CPE, and I think someone just alluded to that, but could you dive into that a little bit?
Yeah, sure.
And I glanced over it.
Let me go back to my slide here. So here's some CPE data. If you look at this and you're trying to build a scanner if you're trying to answer the question as a developer, I'm using a bunch of NPM packages, which ones should I not use? This data is not directly useful to you. There are 4 different routes here, 2 of which I think are project names. Is
this the same CVE?
No, these are 4 different CVEs. Like the links are on the side there. But the point being is it's 4 different NPM packages. which have 4 different representations or 4 different routes, which would lead you to an NPM package.
I guess it's still not super clear. Like, is the CPE data not useful because the versions don't align with reality, or?
No, it's that it's not bijective. There are multiple ways to represent an individual package, all of which may be accurate. There was one I was trying to pull up, which had a single NPM package represented in 2 separate ways in the CPE data. And what I would like you to think about is, like, from a scanning perspective, you're reading in a bunch of strings. How do you interpret what the string means? And without knowing all of the possible paths for, say, an NPM package ahead of time, the strings are not directly useful. Like, there's this CPE dict, which exists, which can aid in this, but you can also just root everything under an NPM directory.
Okay, so I mean, your schema is more specific, I guess.
It's yeah, to NPM data, yes.
One more quick question. Do
Yeah.
you know what percentage of GitHub advisories correspond with a CVE?
No, it's not 100. We do have advisories which do not have CVEs on them.
Is there like a threshold, or it's just based off of whoever's submitting the?
Well, what do you mean by a threshold?
I mean, I'm just trying to understand, like, if we have a program that's just covering, let's say we're subscribing to NVD and we're missing out on all this GitHub stuff, like what is that population that we're missing out on?
Yeah, I'm not sure. I'm sorry. Oh, we might have an answer up here for that.
I know from having talked to Madison about this that CVEs only get filed for a GHSA on request by the code owner. So there is probably a considerable underlap of the two lining up with each other.
So I'm not sure I would say it's considerable, but it does exist. Does that answer the question over there? I'm going to assume yes. Yep. Any other questions?
Can I, since I've still got the microphone, I think there was a bit of confusion about this slide here. Is that 4 different pieces of software for 4 different CVEs?
Yes.
It is. Okay. Yeah. So I wasn't sure if you're trying to make the point that 4 different CVEs were actually for the same software expressed differently with different CPE strings.
No.
I think some of the other people were confused about
that.
Well.
Yeah. Sorry about that. There was one CVE that I've come across that had one piece of software represented in 2 ways. I could not find that to make a slide out of it. Cool. Any other questions or? All right. Thank you much.